It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
A very good evening, all of you guys. Good evening, everyone. Kindly confirm my audio, video, everything is fine. Okay, is it clear? I think people are joining just now. I'll wait for a few minutes. Okay. So, guys, this is the session for what we call DRDO practice session. Today's session, I'll be doing DRDO PYQ of 2008 पैटर्न. ओके. 2008 का प्रीवियस ईयर जो क्वेश्चन पेपर है ना, इस पे नेटवर्क्स का, डिजिटल का, एक दो एनालॉग का क्वेश्चंस और माइक्रो प्रोसेसर, सारे क्वेश्चंस तो सॉल्व करेगा. ओके. नो, ऑब्जेक्टिव क्वेश्चंस ओनली. ओके. Right. So before going further, let me give you some updates regarding my free classes. आप लोग ये QR code को scan कर सकते हैं. Directly you can go through the Unacademy app and my profile. There you will be getting the classes of all my free classes. You can access whichever I have taken on the special class on Unacademy platform. Okay. So July 24th, those who are aiming for the examinations, HPCL exam prepare करने लोग के लिए July 24th you have an exam. I mean you have the mock test all India level HPCL examination. So you can enroll to this exam and you can participate. This exam is on par with your regular HPCL exam, 2.5 hours duration and 170 minutes, where you will be getting your branch examination and also as per the original examination. Okay. So this is the new batch going to start by Sharma sir. That is going to start on I think 21st July. Yeah, 21st July. Aptitude is going to start. This is also one of the right subject by right teacher to start your preparation, guys. So don't miss this chance. 21st we are going to start the new batch. Okay, so for you people, the new offer is going on right now. You will be getting 20% discount with an academy subscription. You can use the unlock 20 code, unlock 20 offer. Okay, so presently this offer is going on with 20% off. You'll be getting, these are the prices. Okay, all these are the benefits of an Academy Plus platform, where you'll be getting the classes by the top educators. So you'll be getting the regular doubt solving session. Test series is completely free for you. इसके अलावा आपको personalized guidance चाहिए तो you can go for the iconic subscription, where you will be getting physical material and many other benefits, one-to-one mentorship. Okay, so yeah, we'll proceed further. Let's start with the problems. Yeah, this is the first question for you. Okay. Samir, you can see there are some questions, some classes of mine in an Academy Flux channel. In an Academy Flux channel, where classes to high ESC mains ka, you can just go through those lectures, you'll get the clarity. Okay guys, so please give a try. For the circuit shown in the figure, the switch is kept closed for a long time, and before it is opening at time t equal to 0, find the voltage VL of 0 plus. Okay, this is the question given in DRDO previous year question paper in 2008. Okay, based on the response, actually for last week, whatever the series we have run, that is TSSP DCL का series में response तो सही है, इसलिए मैं तो A initiative भी शुरू किया, but based on the response I may continue or I may stop after the second class or third class. Okay, I thought of continuing this with DRDO, ISRO PYQ and many other PYQs, but let's see the response, and tomorrow I'll decide whether I'll continue further or not. Okay, so this question pay, what is your answer? For the circuit shown in the figure, the switch kept closed for a long time. Okay, so just before the switching action, since the inductor acts as a short circuit, network is in steady state. Okay, we can replace the inductor with a short circuit. Right. Okay, the switch is closed. So ये तो आपका 10 हो. So इंडक्टर का इनिशियल करंट कितना होता है? I of 0 minus is equal to 1 is equal to I of 0 plus. Now at time t equal to 0 plus, ठीक है, inductor acts as the current source parallel with a open circuit. So you can take a current source I naught which is equal to 1 parallel with a open circuit. ठीक है. Now right, that's all. So switch is opened, right? Okay, switch open तो violation of KCL होता है, ठीक है, but we should not argue with examiner, ठीक है. So आपको क्या होता है सर? This is a 10 volts. So what is the voltage across the inductor according to the polarities given or as per the reference? So you can see VL of 0 plus is equal to minus 10. Actually, current source should not be open circuited. It is a violation of KCL. There must be some resistor here. Then only it makes some sense. But it's okay, fine. So what is the answer is minus 10. Let's move further. Good. Next question. Read this question. For the series RLC circuit, you need to find the current I in amperes. So 25 seconds more. Last 10 seconds. हो गया टाइम. Right. So for the series RL circuit, omega is given by examiner. So what is J omega L here? J omega is 1000 milli. Will cancel J2. Then what is 1 by J omega C? That omega is 1000, this is 1000 and micro will cancel, it will give you minus J. So examiner को क्या चाहिए? करंट चाहिए. इसके लिए मेरा पास एक तो 1 है यहीं पे, ये तो J2, ये तो माइनस J2. ठीक है. सो माइनस J1. सो आपका वोल्टेज कितना अप्लाई किया? 2 एंगल 30 डिग्री. सो आपका करंट कितना होता है भाई? सो करंट तो 2 angle 30 degrees by the पूरा impedance 1 plus J2 minus J1 कितना होता है? J1. So आपको 2 by root 2 angle 45 degrees, ऊपर क्या? Angle 30 degrees. So 2 by root 2 कितना देता है सर? root 2. 30 minus 45 minus 15 degrees. ठीक है. So root 2 angle minus 50 degrees. Good. Rajendra, right answer. Next question. It's a similar, model, but the question here is a basic question. You can give a try. Right? Give it a try. ठीक है. 20 seconds more. The network, find the mesh current I. How to solve this question in 1 minute? Let me show you. Okay, so let me show you that. Here, if you have attended my previous classes, I have given one shortcut with source transformation. Whenever you have a voltage source series with a resistance parallel with another resistance, what is the equivalent is V into R2 by R1 plus R2 in series with R1 R2 by R1 plus R2, 1 by 2, right? Similarly, because this current is I, na, take this current I. You, without disturbing this branch, you do anything, no problem. So the remaining 1 parallel with 2. वन पैरेलल विथ टू कितना होता है सर? 2/3। ठीक है, नाउ बीच में आपने क्या करना चाहिए? द ओरिजिनल 1 ओम एंड फाइंड द करंट आई। हो गया क्वेश्चन। सो ये तो 25, सो आपका आई कितना होता है सर? 25 अपॉन, ठीक है, 1/2 प्लस 1 प्लस 2/3। बिकॉज एग्जामिनर तो रेशियोज में दिया, आप भी रेशियोज निकालो। व्हाट इज द आंसर? एलसीएम तो 6 होता है ना, सो 25/6 प्लस 6 प्लस what is that, 2 2s 4 into 6. Okay, so it will give you 150 by 6 plus 6 12, 12 plus 4 दूसरा लगा रहा है। कुछ गलत किया क्या? 1/2 1 2/3। ठीक है, 1 plus 1/2 plus, right? So the LCM here will be 6। ये तो 3 है ना, so right, so 3 plus 6 9, 9 plus 4 13। So 150/13 is the right answer for the current. What is the required condition? What is the impedance seen by the source? So here, impedance seen by this source, from this side you should see, don't find from here because it's a modified network hai na? So this part will give you 2/3 plus 1। 2/3 plus 1 कितना होता है सर? 5/3। 5/3 parallel with 1 plus 1। So your answer will be 5/3 parallel with 1 plus 1। So 5/3 parallel with 1 can be written as 5/3 parallel with 3/3 plus 1। It will give you 8/3 plus 1। It will give me 11/3। ठीक है, हाँ, 11/8 आ रहा है। ओके ओके, मैं तो शॉर्टकट गलत अप्लाई किया। You should make numerator same। Okay, that will give me 10/8 plus 1 11/8। Okay, I am repeating, listen carefully। So here it is 2 parallel with 1 2/3 plus 1 5/3। 5/3 parallel with 1। So what is 5/3 parallel with 1? I can write 5/3 parallel with 5/5 whenever, okay, then you can write this directly। 5/8 is the shortcut। ठीक है, 5/8 plus 1 will give you the final answer। चलो, let's move further। Read this। गोविंद, ऑप्शन डी। VTH एंड RTH निकाल। Right. Here, again, whatever the shortcut I have given you, use that. Okay. Voltage source series with resistance, parallel with resistance. What is the VTH? Is 20 into 12 upon 12 plus 4. That will give you 20 by 16, 5 by 4, 60 by 4, 15. RTH is, if you replace the voltage source with a short circuit, 4 parallel with 12. That will can be written as 12 by 3 parallel with 12 by 1. So 12 by 4. 3 is the answer. So RTH will be 3 and VTH will be 15. Okay, so let's move further. Okay, next. My options तो 1 and 5. Okay, fine. 5 amperes. ठीक है चलो. Here also again and again I told one shortcut. You can apply that easily here also. I mean, if you have attended my regular class, might be knowing that. Okay, so whenever you have a voltage source series with a resistance, parallel with a resistance, when both of them are equal, it is directly blindly take V by 2 series with R by 2. Here also R by 2 and V by 2, because you need to solve here within less amount of time. You need to solve the problems. So this will be 1 and you need to find this correct. So आपका I कितना होता है सर? 12.5 minus 2.5 by 2. 5 amperes. That हो गया ना? Within less than 1 minute you will be able to solve the question, provided if you understand the concept. The source transformation में I gave this shortcut. Whenever you have a voltage source series with a resistance, parallel with a set resistance, you can replace simply with V into R2 by R1 plus R2 series with R1 R2 by R1 plus R2. अगर R1 R2 सेम है तो V by 2 series with R by 2. ठीक है? Let's move further. तो छोड़ दो. ओके, सो दिस इज एक्चुअली एक कंट्रोल सिस्टम्स का क्वेश्चन है, बट हम भी कर सकते हैं इसको, राइट? Using our networks knowledge also, we will be able to do it, not an issue. Not very sure about it, Nisha. I think it is yes. Time up. Okay. So the state space equation for the circuit shown in the figure with the x1, x2 are, you need to find the equation for dv naught by dt. That is your x1 dot. It is nothing but the current in the capacitor. Okay. So, and what is that with respect to V and I? dV naught by dt is your IC, right? Your IC is equal to, okay, I can write like this. X1, what is dV naught by dt according to the options? Okay. The similarly, X2 is di by dt. Okay. This is voltage across the inductor by L. Okay. This is X2 dot. Okay. So X2 can be written as X2 dot is what is that? Uh, X2 is di by dt. Di by dt is voltage across the inductor by L. Voltage across the inductor by L. Fine. These two are the informations we are having. Okay. Now, what is the examiner given condition? Okay. So x1 equal to I and x2 equal to V naught. Okay. So here, if you take the current I here, okay, this is the V. What is your voltage V of t? V of t equal to VR plus VL plus VC. But what is VR? That is I into R. What is the voltage across the inductor? What is the voltage across the inductor is L di by dt. L di by dt is this one. L into di by dt. What is the voltage across the capacitor? Let's take the voltage across the capacitor as V naught is your V. So now just manipulate this equation. What is L di by dt? Your V naught is equal to, take that other side, minus V naught, okay, plus R into I, okay, just a moment, minus V naught, okay, you take this other side, minus V naught, okay, minus, yeah, minus R into I and plus V. Okay. So here as per examiner notation, this is you take L other side. What is di by dt? Minus V naught by L minus R by L into I plus V. Okay, this can be written as x2 dot because di by dt is your x2 dot is equal to minus x1 by L. Okay, minus x1 by L. Then what is I? I is nothing but your x2, right? Minus R by L into x2 plus V. So you can write this as x2 dot is equal to minus 1 by L minus R by L into x1 x2 plus, okay, plus 1 into, okay, this is first row. So x2 dot ka row must be 1 by l. Okay, must be minus 1 by l minus r by l plus 1 by l. This is the right option, and this is also sure, this is also right option. So ये दोनों में एक आपका आंसर होना चाहिए. So eliminate the remaining. Next, by using the same concept, find x1 dot also. What is x1 dot? dv by dt. Okay, so just a moment. So here, instead of KVL, you can use so C dV by d naught is your current, right? So the current here will be C dV by d naught. C dV by d naught is equal to, so C dV by d naught is equal to I. Okay, so very simple. What is dV by d naught? I by C. But dV by d naught is your x1 dot. X1 dot is equal to, you can say, 1 by C into I. I is x1 plus 0 times x2 plus 0 times v. So that will give you in terms of x1 and x2. Sorry, this is x2 now. तो कुछ गलत उल्टा किया क्या? x2 is I. x2 is I. x1 is v. Now it is fine. Okay. Yeah. x2 is I. x1 is v0. So x1 dot is equal to fine. Now it is perfect. So if you write them in the matrix form, you will be getting the option C. Okay. So 0 times x1 plus 1 by C, x2 plus 0 times v, and this one. Fun. Sayuj, tomorrow 9 p.m. you can join the session. Next question. Try this question, guys. It is the most famous question. This same question appeared in GATE ESE 2021. The same question appeared in this exam also. I mean, exam ka matlab DRDO 2008 also. Very good. Tell me. Tomorrow also we have the same session at 10 p.m. guys, because I have special class 9 to 10, so 5-10 minutes late we start the session. Tomorrow I'll try to solve 2009 ka question paper. Based on the response, the day after tomorrow I may continue it. Good. Option C is wrong, yeah. Options, अरे क्या हुआ? ऑप्शन सी में डबल ई प्रॉम दिया ना, डबल ई का मतलब क्या? इलेक्ट्रिकली एरेजेबल. ठीक है, डबल ई का मतलब इलेक्ट्रिकली एरेजेबल. नॉर्मल ई प्रॉम इज इक्वल टू यूवी ई प्रॉम. By sending ultraviolet light, you can erase the stored signals. UV EEPROM and normal EEPROM दोनों same. ये तो बहुत इंपॉर्टेंट क्वेश्चन है, बहुत बार सारे कॉम्पिटिटिव एग्जाम्स पे आया. सो फैक्चुअल क्वेश्चन, प्लीज रिमेंबर द कंटेंट. राइट. 9 PM तो नेटवर्क एनालिसिस. आज तक डिजिटल हो गया. Tomorrow onwards we'll start network analysis. Next question. Try to read this question. Fine. You people know triple counter is not a synchronous counter. So in 8085, accumulator is 4-bit register, 8-bit register, 16-bit register, 32-bit register. Very good. Okay. 8-bit. 8085 facts are important. 8-bit data bus, 16-bit address bus. All registers are 8-bit registers except program counter and the stack point. Okay. Similarly, 8086 में it is having 16-bit data bus and 20-bit address bus, which is having 1 MB memory capability. This is given in DRDO paper. ठीक है, 2008 का. Next question. ये डिजिटल का क्वेश्चंस तो आसान से आया. I mean most of them are factual questions ही आया. I hope you people can answer this easily. The second time thereon, just read and say the answer. I think everybody might be able to answer this question. हो गया time. Yes. Latch is level triggered. Flip-flop is edge triggered. Next question. This is from logic families topic. Now it is not available with the gate. If you know the concept, you can answer. Schottky TTL. The Schottky diode increases the propagation delay, increases the power dissipation, prevents the saturation of the output transistor, keeps the transistor in the cutoff region. Time up. Yeah, it will not what we call increase the propagation delay. It is the main reason we use it. It will not allow the transistor to go to complete saturation is what it will do it. Okay. Next. This is another easy question for you from digital circuits. Actually, in TTL logic family, you have different TTL, uh, low power TTL, low power Schottky TTL, all these variants. Okay, 74 series, 74S, 74LS, 74L. All these are the different series available in TTL. In that 74S, we generally have the IC 74S means so Schottky, right? So for the multiplexer shown in the figure, the output expression Y will be. So you can give a try. Yes, Amit and SK, right answer. Right. Here you can say it is the sum of the minterms 1, 4, 5, 7. Okay, so if you take a K-map A, B, C 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, 4, 5, 7. So this is your expression which will give you A, B bar, A, C, B bar, C. A, B bar, A, C and B bar, C. Right, that is your option C. This is a good question. You can try. So please give a try. Option, let's see. Okay, omega equal to root 2 omega naught. You know, omega naught equal to 1 by root LC. Omega naught square equal to 1 by LC. So it will give me the, because options are with respect to L only, I want to eliminate C as 1 by omega naught square C. Right. What is your Z in the series RLC? R plus j omega L plus 1 by j omega C. Okay, so now omega equal to, what is that, root 2 omega naught. So j root 2 omega naught L by j root 2 omega naught, omega equal to root 2 omega naught. Okay, substitute that. And C can be written as 1 by omega naught square L. Okay, so here omega naught square cancels. Okay, so this will go to the numerator. So R times j root 2 omega naught L. You take to the numerator minus j. This omega naught will go to the top. Root 2 into L. Okay, so here cancel over right? Yes or no? 1 by root 2 into L, because root 2 is in here. So what is your Z? R plus j times root 2 j times omega naught L, you take common, into root 2 minus 1 by root 2. That will give you R plus j omega naught L. Take the LCM, root 2, that is will give you 1 by root 2. Got it? So R plus j omega naught L 1 by root 2. Option B. How many of you gave option B? Thank you, Ahmad. Okay. Option B is the right answer. Chalo. So let's see this question from diodes, that is analog. Last question. It is a linked question given. So the first question here, try to answer it, then we will see the second one also. So you have given two diodes, which of the following statements is true? दोनों ऑन हो जाएगा, एक ऑन एक ऑफ हो जाएगा, ऐसा. Right. So guys, see here. %, दोनों ऑन तो नहीं हो जाएगा, क्योंकि दो वोल्टेज सोर्सेस ऑफ डिफरेंट वैल्यूज कैनॉट बी कनेक्टेड इन पैरेलल. ये तो वायलेशन ऑफ केवीएल. इट इज इम्पॉसिबल बोथ कैन बी ऑन. गलत भाई. So you can start with the assumption both are off or any one of them will be off. Okay. So when any one of them is off, on, say for example, assume, because it is showing like that now, -9 is forward biasing, this reverse biasing. So it is a positive general assumption. I can assume D1 on. I may be right or mostly, or I might be wrong also. To cross check that, okay, on diode को short करके you should find the current in that diode. Off diode को open circuit करके you should find the voltage across the diode. So these are the conditions we need to check. Off diode पे VD negative, on diode पे ID positive होना चाहिए. So here you have, what is that, 2 volts. Here you have -2. Now both are connected here, 10K, and what is this node voltage? -9. So what is this current? This current equal to -2 minus of -9 plus 9 by 10K. That will give you 7 by 10k 0.7 मिली एम्पियर. यस, मेरे को पॉजिटिव करंट आया, मेरा एजम्पशन सही है, राइट. सो व्हाट इज दिस करंट यार? 0.7 मिली एम्पियर. यू कैन टेक द ड्रॉप. नहीं है तो दिस नोड वोल्टेज इज सेम एज दिस -2. सो इट इज 2 and this is -2. Okay, this will be -2 with respect to ground. Just take the KVL. Okay, KVL say what is your answer? Negative to positive 2, positive to negative minus VD2, negative to positive plus 2 equal to 0. Okay, so आपका VD2 will be equal to 0. It can be 0 or negative, both the cases it is reverse biased. Right. So or simply it is 2 and -2. The net difference will be 2 minus -2 is 4 हो रहा है. Wait. If you turn on this diode to -2 here, okay, then compulsory this -2, 2 is more positive, -2 is more negative. Definitely it should turn on D2. So compulsory it is not possible. Just a moment. Ideal case तो बोला. So both are on to impossible है ना. Just a moment. Let me cross check it. When both are off, what happens? Okay, so here this -9 will come to this node. Okay, what is your VD1? What is your VD2? Okay, so at this node you have -9, at this node you have +2. What is VD2? VD2 is 2 minus -9, 11. Okay, this one -2 minus -9, 7. Okay. So you can say this is more forward bias. Okay. Then you will get here +2. Correct. And +2 will reverse bias this diode. Sorry. Okay. So what is the condition is D2 on, D1 on. Okay. It is not possible. Right. So again, because VD2 is not negative here. VD2 is 2. It is 4 na, so your assumption is wrong here. So compulsory ulta hona chahiye. Okay, so D2 will be on and D1 will be off. Okay, so please listen here. Okay, D2 will be on and D1 will be off. So because VD1 will be after you short circuit here, This 2 will come here. VD1 is 2 minus 2 minus 4. Perfectly correct. So this is on. Okay. Right. So that is about yes, yes, D1 off, D2 on. So examiner को ये भी चाहिए V naught. When D1 is on, your V naught is how much? Undoubtedly, this 2 will come here. So V naught is equal to 2. What is the current I? I is equal to 2 minus minus 9 plus 9 by 10. 11 by 10. 1.1 ampere. 1.1 K na milliampere. I hope it is clear. Right. So that is the final answer, guys. So that is about your today's class. We have done around 20 questions in this available time. Tomorrow we will catch up again at 10 p.m. With a similar kind of session. Mostly I'll be solving 2009 ka question paper. Okay, of DRDO. So is it fine, guys? Can we proceed further? Yes, thank you. So before the price hike, if you want to take the advantage, you can take the Unacademy subscription now. You can avail the 20% off. You can use the code Shankar10. Okay. So thank you for your time. Abhi to we'll meet again tomorrow. Thank you. Okay. Thank you, thank you, thank you. Tomorrow we'll meet again. Okay, good night. See you all.